All right, example 3, add 4 over b plus 1 over c plus 1 over 2. So once again, the directions say add. Again, I see fractions. So again, I immediately, as soon as I see fractions, I focus on the denominators. And I can see this one very clearly, they're not the same, right? So this comes to that, down to that least common multiple thing. All right? And when we look at least common multiple, we're worried about the prime power factorizations of those denominators. These denominators are pretty basic denominators, right? B can't be factored, C can't be factored, 2 can't be factored. So they're already prime. Everything's prime, right? And if I'm trying to find the least common multiple of a group of things, and again, I'm just finding the least common multiple of the denominators, I write LCM equals, I write every single thing that happened, which is 2b and c, and I take the highest power of each one, first. Multiply those together. 2bc is my magic thing right here. Okay? That's how you find the least common denominator. Simply apply the least common multiple procedure to the denominators you're looking at. And again, right now they're going to be pretty basic. More often than not, just multiplying the denominators together will get you the least common denominator. At least one of the problems we're going to look at today doesn't do that. We're going to get a better least common denominator than just multiplying everything together. But more often than not, that's what happens. Okay, now, I don't know about your techniques for adding fractions, subtracting fractions. I'm going to show you my technique. I'm not going to say my technique's better than yours. If you know how to do this, fine. If you don't, fine. I would recommend my technique as I find more efficient than anything I've ever seen. That's my opinion. It's my technique too, so maybe that's why I think that. But if you've had struggles with fractions before and now all of a sudden we're throwing letters into the mix, if you start fresh with a technique that I'm showing you right now and you master that technique, I promise you fractions will become easier. Here's what my technique looks like. Once I've established least common denominator, I make one big fraction bar and I put that on the bottom. Okay? In anticipation of having several things being added or subtracted on top. So I'm allowing myself this big fraction that's going to be created. Then what I'm going to do is I'm going to look at each fraction individually. So I've got this one here. It starts off as 4. All right, 4 is the numerator, so I put a 4 there. And then in parentheses, what I want to ask myself is this simple question. How did the denominator from this fraction, b, change to become 2bc? What's new?
Minus by 2c.
2c is new. Does everybody see that okay? This is what the denominator was. This is what the denominator became. b was already there, right? So 2 and c are new. So 2 and c are going to be multiplied by the top. So the common denominator has already been established here. I'm just creating a new numerator to account the change I made to make the denominator I wanted for that one fraction. All right, moving along. The second fraction is 1 over c. So I'm going to put plus 1 because 1 was the numerator. Then I'm going to put a parenthesis next to it. The denominator was c. There's c. What's new?
2b.
2b. b is new, 2 is new. The 2 and b are both new. So b times 2 are going to be multiplied by 1 for that middle fraction to account for the change that occurred. This is what the denominator was. This is what the denominator became. This was there. This is new. That's what the top's going to be multiplied by to account for that one fraction changing. Third fraction is plus 1/2. So I'm going to put plus 1 because that's what the numerator was. And this denominator was 2. What's new?
bc.
BC is new. So for that one, I'm going to put a BC next to it. Okay, so I had 3 fractions to begin with. I got 3 numerators to account for. The original numerator 4 times what changed the bottom. The original numerator 1 times what changed the bottom. The original numerator 1 times what changed in the bottom. And just like that, that's my answer. Not completely simplified, but at least I'm to the point where I can just make each thing better now. So all this goes over 2bc. Then I just fix each one individually. Can I make 4 times 2c any prettier? 8c. Perfect. Anytime you can multiply things together, you should. So don't leave it as 4 times 2c. 4 times 2 makes 8, so it's 8c. Can I make 1 times 2b any prettier?
2b.
And plus 2b is what we get out of that one. Can I make 1 times bc any prettier?
BC.
Just bc. Ones aren't necessary to be written in front of numbers, in front of letters, so that would be the final answer. I can't add these because they're unlike terms. This has a c, this doesn't. This has a b, that doesn't. This has a b and a c, but nothing else has both a b and a c. So we have no ability to add or subtract the stuff on top. That's as far as I can go with that problem, and I'm done. Get into the question of reducing like Amber asked on the other one. This has a C, this has a C, this has a C, this doesn't. B, 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 no B. 8, 2, and 2 all divide by 2, but that doesn't. All right, so nothing evenly divides all the stuff, so we can't reduce that at all. So that's as far as we can go with that. And that's more often than not, that's how they work. Each term gets simplified and then you're done. Like terms don't happen very often in these problems.